Same old live stream. Today we are going to resume our old Matlab progress. Okay, so let's start. Visualize multi-body system. A closer look at mechanical explorer. Okay, let's start with the exercise. So what we have to do, we are just going to make a simple multi-body. What is taking time? Allow. Okay, so this is the window where we have to do the training and assessment. Now, okay, so this is the 12 side coin flip and this is the flow. Now what we have to do, we have to add three types of block here, which is solver configuration, which will do the calculation related to mechanical system. Solver configuration. Then we have to add mechanical, which will determine the parameters like gravity and speed for our coin and the flow. And last but not the least, that is world field, world frame, which will act as a base, or you can say ground for our configuration, for our model. Now what we have to do, we have to just connect this like this. Okay, so now this is connected. Now next thing what we have to do here, connect those three blocks diagram together, then connect the floor reference port R. This is the floor reference port R to the world frame port W. This is the world frame, so I will connect it like this, and then we will, but leave the 12 side coin W. Okay, first act is done. Now familiarize yourself with mechanical explorer or mechanics explorer interface. You can go to the mechanical explorer, which will come in simulation, no. Setup in hardware, run, customize, no. No, it's model verification. So we need mechanical explorer, model advisor, model transform, matrix, coder, model slicer, model design, no. Then we have to go real-time simulation and testing, no. Code generation, no. Signal control system, steady motor stabilizer, robotic operating system, ROS, which is stand for real-time OS. Favorite for model linearizer, C courage, simulation. Okay, so in this I cannot find the model mechanical explorer. Can I find it here? Nope. There is no interface like mechanical explorer, model explorer. Let's go to the model explorer. Yep, this is the model explorer. So now what we have to do here, now what we have to do, rotate the viewpoint to see the reverse side of the coin. 12 side coin. How can I view this content? View. I can't view the content. Okay, so I don't know where to go. Once you're ready, debug, update model, transition diagnose. Okay, see solution. Click the font this or the isometric button to view the mechanical explorer. Where is this font? Because I cannot able to see the font here subsystem. Nope, I cannot find the proper. Okay, submit. Now the task is add the rigid transform. Rigid transform. This is a rigid transform. Block from the multibody frames and transform you can to your model and connect the B port of the world frame to the world frame. So this is the B port and I have connected it to the world frame and its follower F port to the 12 side coin. Now in the dialog box expand the transition. In the dialog box expand the transition set to standard axis and set the value to 20 centimeters plus z axis. Yep. Click on the update model which is in the debug mode. So I've updated the model to see the changes in the mechanical explorer. Yep. In the hierarchy view of mechanical, click the rigid transform. So basically this part is known as hierarchy. Click on the rigid transform. You can see the rigid transform is correctly placed at the center of the coin. In the rigid transform box, I have to kick the standard axis in the rotation box and then I have to right click on the 45-degree shift with the minus y axis degree. Again we have to click on submit. Now we will run the simulation here. Multibody explorer. Yeah. Now we will run the simulation here. Let's see the result. Okay, so it is now at 45-degree, which is good. Next thing what we have to do, add the 6 DOF block, which is 6. Yep. Connect the base B to the rigid body transform F. Okay. And then we have to okay, so basically it is same. Okay, so this is called as a connect the base of connect its base B port to the rigid body F, to the rigid body F. Yes, so again I will going to connect it to the F, control I, That is perfect. And then we will connect this to this, and we have to disconnect this connection here. Yes, all three boxes. Run the simulation. To run the simulation, we will go to this and we'll go to run the simulation here. Yep, you can see the coin is flipped. But now the next thing that we have to do is flipping, and the flipping is the most important thing we have to do and we have to perform. For that, in the 6DOF joint dialog box, which is this, it is nothing but the parameter box. Expand the X prismatic primitive. Oof. Then go to the stage target and specify the velocity to 30 meter per second. This setting gives the coin a translation velocity along the X axis. Finally, to spin the coin about the Y axis, expand the spherical primitive and go to the state target. Again, we have to go to the target velocity and we will write the parameters in the 3D. So it will be 0, 0 and 60 in RE. Okay, so I cannot write that, I guess. REV by S. Okay, so again we have to run the simulation here. Now let's see the problem. Something went wrong because my model is not acting according to no, there's a problem. We have to fix that. How can we fix that? Simply we will again centimeter per second. Okay, now let's see again. Yeah, now the coin flip animation is perfectly working, and this is the best thing that I have ever did with the help of maths.
Modeling a multi-body system is a lot like putting together an intricate 3D mechanical puzzle. Imagine your
Okay,
task.
so wait for 2 minutes.
With creating a functional model of a passenger car. It sounds daunting, right?
Yes.
But no worries, with Simscape Multibody, you've got this. Start by breaking down the big task into manageable chunks. Sketch out the car's overall structure, weight, and dimensions, focusing only on the main parts, like the car body and tires. Leave the finer details for later, since they don't significantly affect the vehicle dynamics. For instance, you can use a brick to represent the car's chassis, simple cylinders for the wheels, and bam, you've got a rudimentary
It's
car.
like a
It
2D
may not
car
win any
or
beauty
2D bus.
contests, but hey, it can get you where you need to go.
Yes.
Simscape Multibody provides a comprehensive library of solid blocks that enable you to model a wide range of 3D mechanical systems.
So
These blocks are like the individual pieces of a 3D puzzle, which you can customize and combine to create real-world multi-body systems. Let's take a look at the brick, spherical, and cylindrical solid blocks. You'll frequently use this elementary trio as a starting point in your multi-body models. The brick solid block serves as the backbone of many systems. This block is versatile and can be resized to fit your needs, much like a construction brick. You parameterize a brick by specifying its length, width, and height as a 3-element vector. resulting in a brick-shaped 3D model. For example, you could use multiple brick solid blocks to define the body of the car. You can even choose its color and transparency. Next, there's the cylindrical solid block, which lets you create parts that are cylinder-shaped, like the car tires. By setting the radius and length, you can create cylinders of any size. And finally, there's the spherical solid block, which creates sphere-shaped objects. All you need to do is specify the radius, and your sphere is ready to go. Picture a car with spherical wheels. Parallel parking would be a piece of cake. The spherical solid block would be perfect for modeling such a futuristic ride. Once you've created all the necessary parts, you can connect them together to form your car, just as you would assemble a car in a factory. In summary, starting with basic shapes to create a complex mechanical system is at the core of Simscape Multibody. Start with simple, well-defined pieces and connect them at the appropriate locations. Once your model behaves the way you want, you can circle back and add finer details to give it a more realistic appearance. And just like that, you'll soon have a multi-body system whose dynamic behavior mirrors that of the real world. Whether you're making a car, a drone, or a robot, it all starts with these basic shapes.
Are different types of solid. Start by adding a load on one side of the beam. How can I do that? It is not. In this activity, you will model a simple. Okay. Start by adding a load on one end of the beam using brick solid block. We have to use brick solid block. Okay. Yes. Beam brick. We have to go to the geometry. After geometry, dimension parameters. .4 space. Okay, so we have to give the same parameters here, so it will act as a brick. Next, in the okay, in the beam brick transform Open the parameters and set offset to -1, 0.2 and 0. Sorry. In meters. This will move the brick to the left side of the beam along to the x-axis, and by half its weights along the y-axis. You will learn the rigid body transfer later in the course. Run the simulation. Does the lever mechanism trip one side yet? Let's see. No, it's not tripping one side yet. Why, I don't know. Let's go to the debug and update the model. After that we will again try to run the same model here. Still the same problem. It has to be on the one side. Okay. I think the problem here is that it is set to the perfect parameter. Okay, we will see about that later. Place a revolute joint. Yes, we have to add a revolute joint between the function and the beam. So we have to add a revolute joint here. Sorry, fulcrum. Yes, it is perfect. Let's run the simulation. Yeah, it is working perfectly fine now. Because of the joint, the body is moving. Add a spherical block. Spherical SPH spherical solid. Control I. Then we have to go to the radius. We have to set the parameters for the radius. Currently it's set to 1. We have to set to 0.5. No, 0.1 meter. And in the so we have set the parameter here. And now we have to go here, and then we have to write manually the offsets. It is 1. Okay, now, oh sorry, we have to use different types of no, this perfectly set to Cartesian. Next, let's see the simulation. Now the ball is not going that way, but okay, it is not. Double click on the brick solid. The brick solid. Then we have to go to the inertia. Then click the inertia button in the tool strip to see the solid initial property. What No, this is not a solid physical property. Is this the brick solid? Double click the solid brick. So this is a brick solid block. To open its dialog box, click the inertia button. Okay, it is in kg 1. It's 1, not 60. You can see the mass 1 kg. Okay, sorry. So first of all, we have to go here, then we have to go to the inertia block. The brick's mass was 64 kg. Double click the spherical block. After that, with the 32 kgs. 32 kgs. Okay, so you can see the solid density is changed. What is the solid density? How can I know the solid density? Next task. In the beam brick, transformation box, change the offset along y-axis, sorry, x-axis with 0.5 away from the fulcrum. Okay, so the thing I have done wrong is, instead of this, what I have to do, I have to write this 0.5 minus 0.5, 0.2 and 0. Again it is wrong. that require the scalar value. Okay, so for scalar value we have to go to this part. So instead of -1 it is will be 0.5. Okay, now it is perfect. Now we have to again simulate the model and let's check the, it's perfectly fine, but why? Yes, it is now perfectly fine. Next task, next session.
Moving beyond the familiar territory of bricks, spheres, and cylinders, it's time to learn about three more members of the solids family: the extruded, revolved, and file solids. If solids with standard shapes are like basic puzzle pieces, the extruded, revolved, and file solid blocks are tailor-made puzzle pieces, shaped precisely to fit your specific needs. Let's begin with extruded solids. Picture yourself baking cookies using a cookie cutter in a specific shape, like a star. You press the cutter into the dough and lift it out, creating a beautiful star-shaped cookie.
Yes.
Extruding solids in Simscape Multibody follows a similar process. You start with a 2D profile defined as a matrix of XY coordinates in Matlab. Each row in this matrix corresponds to a point on your cookie cutter. And the dough you're shaping? Well, think of it as the material you're about to extrude. You pull or extrude the material along the Z-axis, creating a 3D solid with a custom cross-section. You can control the extrusion amount by changing the length parameter in the dialog box. Now, be mindful that, just like following a recipe, there is an order that you must follow. The points in your profile are arranged in a specific order, like following a path on a treasure map or joining dots on a piece of paper. If your path goes counterclockwise, you get a solid region. If it goes clockwise, you get a hollow region, like a donut hole. Now let's turn to revolved solids. Imagine you have a piece of flexible wire in a specific shape, like an L shape. You then rotate this shape around a fixed point, much like spinning a jump rope. That rotation creates a 3D object. In our case, that's a revolved solid. You still start with a 2D profile just like before, but instead of extruding, you spin the shape about the Z-axis. Your spinning can be a whole 360 degrees, creating a full 3D shape. Or it can be a partial rotation, sweeping symmetrically around the Z-axis.
This will be the perfect for making the gears.
In a nutshell, extruded and revolved solids in Simscape Multibody are all about taking 2D profiles and turning them into 3D shapes through extrusion and revolution. It's a pretty big step up from the basic shapes and a wonderful tool to add to your 3D modeling arsenal. But what if you need more intricate shapes? Or what if you already have a design for a part in CAD software? That's where the file solid block comes in handy. It allows you to import exact shapes of individual parts, or even entire assemblies, directly into your Simscape Multibody model, saving you time and effort. The block supports popular formats like STEP or STL, which are common file types for 3D objects in these programs.
Okay.
With the addition of these blocks, your toolbox is now more versatile. You've moved beyond the basic building blocks and now have a range.
Okay, so I have to write this because this will be much more easier. Brick solid, spherical solid, cylindrical, extruded solid, revolved solid, and file solid. Okay,
Of specialized pieces to help you create more complex and detailed 3D mechanical systems
like
in
making a
SimScape
drone.
Multibody. Now, let's take these new tools and see what you can create.
So these are the different types of solids that we can make. So first task that we have to do here is add an extruded solid. EXTRU extruded solid block in your model and connect it to the world frame. Okay. In the block dialog, expand the geometry. In the block dialog box, expand the geometry, yes, geometry section, and change the number of sides to 6. The outer radius is 4 centimeter. 4 centimeter, and the length is 58. Okay. Okay. Is it in mm? No, it is in millimeter. I need it in mm. The radius size has to be in centimeter. Okay. Let's check again. Yep. This is the perfect 3D model block that I can make in a. Next task. The point defining the cross section are already defined for your Matlab. Reopen the dialog box for extrusion solid. Change the extrusion type. And how can I change that? Okay. Regular to journal. Then change the cross section. How do I change the cross section? GRIPPER. Okay, gripper basics in meter. And it is set to 50. Yes. To change the color of the solid, go to the graphics, go to the visual property, go to the advanced. Okay, go to the visual property, set the change the color diffusion color to gripper color. That's all we need. Refresh. So you can see here, this is the gripper that we needed. And it is like CAD. Next task. Change the cross section parameter of yes, it is in M. Gripper holes. I don't know how can I change it to the section area to GRIWR, gripper holes to in mm. Next, change the cross section parameters sorry, detail in mm. Delete the extruded solid block. Delete and replace it with a finely solid. Control I. Okay. Then we have to go to the geometry. Then we have to name the file, that is GRIPPER. Sorry, GRIPPER. Here is the name. As the file name. Then in inertia section, change the based on to custom density, and it has to be specified by 150 kilogram per meter cube. Okay, let's see. Yes, the gripper is perfectly working fine. That's all we needed. Okay, so how much is completed? So the model bodies, we will complete this part, and then we will proceed towards position and orientation bodies and assembly bodies in the next video, and in last video we will go to the project part. Okay, starting with the small pixels or small squares. 87% of the portion is already completed. Just need to complete this resolved solid blocks. Okay, so here we have to do the antenna stuff. For that, what we have to do, connect the satellite base top. Satellite base top. We have to connect this, which is satellite. Connect the satellite base top port to satellite base top port to the satellite joint port B. Satellite joint port B. Okay. In the satellite joint dialog box, satellite joint dialog box, expand the geometry, go to the extension of the revolution 45 degrees, 45 degrees. This will be the 45 degree. Okay, next task, connect the satellite joint F to this. Am I right? And in the dialog box of satellite dish, So let's change the extension rule to custom and full. Custom and full. Okay. Okay, sorry. Evaluating parameters. Custom to full. Custom to full. Okay. Now my satellite is rotating perfectly. Okay, that's good. With this, we have completed the module of this course, and we will go towards the quadcopter in next video. Till then, bye bye, and we will learn about more on the basis of multibody in next video.